Welcome to Career Guidance Max playlist. In this video, I'm going to start Unit 4 Integral Calculus. In this video, I'm going to start the trigonometric substitution method. Rest of the sections we'll see later on. Okay, first I will complete the important section from this unit. That is trigonometric substitution model. From this section, you will get 8 mark from university, but it's very simple only. But you should know the expressions. What are all the expressions given in your problem? Here, I given some 3 expressions. Square root are not mandatory. Just you should know what is the expression. A square minus x square means we can substitute x equal to a sin theta. And square root of a square plus x square means we can substitute x equal to a tan theta. And the square root of x square minus a square means we can substitute x equal to a secant theta. The first two limits are minus pi by 2 to plus pi by 2. And last one is 0 to pi by 2 to or pi to 3 pi by 2. So these are the expressions we have to apply while doing the problems. So before going to start the problem, you should know some basic results identity. Already you know that first one minus sine square theta is, we know cos square theta, because cos square theta plus sine square theta equal to 1. From that we can arrive this. And 1 plus tan square theta equal to secant square theta. And secant square theta minus 1 is equal to, shift this, I will get tan square theta. Cos square theta equal to 1 plus cos 2 theta divided by 2. Sin square theta equal to 1 minus cos 2 theta divided by 2. And one more term, integral secant theta d theta. Integral secant theta d theta means you should write log of secant theta plus tan theta plus c. Indefinite integral means finally we have to add one constant. And sin 2 theta equal to 2 sin theta cos theta. These are all you should know. While doing problem, I'm going to apply all those things. Okay. So we'll start the problem now. The problem number 1. So evaluate integral x square divided by square root of 1 minus x square into dx. Consider, you can take I equal to integral of x square divided by square root of 1 minus x square into dx. This problem I am going to solve by trigonometric substitution method. Okay. So here our expression integral x square divided by square root of 1 minus x square into dx. So this expression is represent in trigonometric substitution model. Square root of a square minus x square means we can substitute x equal to a sin theta. This is our substitution value. But here instead of a square equal to, here you will have 1. So when you are substituting the value here a equal to 1, so you can put x equal to a equal to 1 sin theta. Okay, put x equal to sin theta. So this x I am going to differentiate with respect to theta. Dx divided by d theta equal to sin theta differentiation cos theta. I'll write dx equal to cos theta into d theta. Okay, I'm going to substitute this in our integral term. So I'll write integral equal to integral of x square, x is sin theta whole square divided by square root of 1 minus x is sin theta whole square. Okay, this dx I'm writing cos theta into d theta. Sin theta whole square we can write integral of sin square theta divided by square root of 1 minus sin theta whole square. I'll write 1 minus sin square theta. Here we have cos theta into d theta. Okay, so next I'll write integral of sin square theta into cos theta into d theta divided by 1 minus sin square theta. I will write cos square theta. 1 minus sin square theta we can write cos square theta. Then here I will write integral of sin square theta into cos theta d theta divided by square root of cos square theta, we can write cos theta. Okay, now I cancel this both cos theta. I'll get integral of sin square theta into d theta, right? So then integral of the sin square theta, I will write 1 minus cos 2 theta divided by 2 into d theta. Okay, so here I replace sin square theta equal to our formula 1 minus cos 2 theta divided by 2. Here I will integral this 1 minus cos theta divided by 2. Before that I will take outside 1 by 2. So here I will write that I equal to 1 by 2 integral of 1 minus cos 2 theta into d theta, right? Now you can integrate with respect to theta 1 by 2. First one, there is no theta term, it is a constant. Integrate with respect to theta, I will get theta. And cos 2 theta integration minus sin 2 theta divided by 2 and plus c. Okay, here I'll write 1 by 2 theta minus sin 2 theta, I will write 2 sin theta cos theta divided by 2 plus c, right? Here I will cancel this 2. I will write 1 by 2 theta minus sin theta cos theta plus c. So we substituted here trigonometric values. Finally we have to convert. So here theta, how to find the theta? Here already we know x equal to sin theta. From that you can find theta. Theta is equal to sin inverse of x. Sin theta directly we can replace x. Then cos theta, already we know cos square theta equal to 1 minus sin square theta, right? That means cos theta equal to, we can write square root of 1 minus sin square theta. Okay, here you can substitute that values 1 by 2 theta, we can replace sin inverse of x, and minus sin theta we can replace x, cos theta we can replace square root of 1 minus sin square theta plus c, right? Here sin theta already we know x, you can substitute there 1 by 2 sin inverse of x minus x into square root of 1 minus sin square theta. Sin theta you can substitute x, I will get x square sin square theta means. So this is your final answer for this sum. The very simple one, just you should know how to write the beginning value x. Here a square minus x square expression means we have to take x equal to a sin theta, but instead of a, here they given 1. So you can replace a equal to 1 here, I will get x equal to sin theta. This term you can differentiate with respect to theta, you will get d theta. Instead of dx, we can replace cos theta into d theta. Remaining all values you can substitute and simplify. This model is very simple, okay, very simple, you can see. Next we'll start problem number 2. Problem number 2 is evaluate integral dx divided by square root of 4 plus x square. Okay, apply trigonometric substitution method. So I will take integral I equal to integral of dx divided by square root of 4 plus x square. Okay, here in denominator your expression square root of 4 plus x square, which is we can write a square plus x square. So the expression is considered plus square root of a square plus x square means we can replace x equal to a tan theta. Instead of a, here a square equal to 4 means a equal to 4, we can substitute. So now I'm going to differentiate this x term. I'll get we can write first x, put x equal to a equal to 2, not 4. Put x equal to 2 into tan theta, because a square equal to 4, a equal to 2. Okay, and differentiate this term, dx divided by d theta equal to 2 into differentiation of tan theta is secant square theta. So I'll write dx equal to 2 into secant square theta into d theta. Okay, now I will replace in our integral term, integral equal to dx, I will replace 2 secant square theta into d theta divided by square root of 4 plus x will be 2 tan theta whole square. Okay, from that next I will write 2 secant square. So next I'll write here as 2 secant square theta d theta divided by square root of 4 plus square this term, 2 square will be 4, tan theta whole square we can write tan square theta. Okay, so next integral 2 secant square theta into d theta divided by, here I'll take 4 outside commonly, 4 of 1 plus tan square theta. Then I'll write integral 2 into secant square theta d theta divided by square root of 4 will be 2. Remaining I will write in square term 1 plus tan square theta. Okay, this 2 will cancel. I will write integral secant square theta d theta divided by square root of 1 plus tan square theta. Already I given the formula. We can write here secant square theta. Okay, the square root of secant square theta we can write secant theta. Secant theta will cancel. We will get integral of secant theta into d theta. Okay, so integral of secant theta into d theta means we will replace I equal to integral of secant theta d theta. We can write log of secant theta plus tan theta. Log of secant theta plus tan theta plus c, right? So we can write log of secant theta plus this tan theta I am going to write based on this value, x equal to 2 tan theta means tan theta equal to x by 2. Okay, here tan theta will replace x by 2 plus c. This secant theta how to replace? Already we know secant square theta equal to 1 plus tan square theta. Okay, from this I will write secant theta equal to square root of 1 plus tan square theta. So in our term I will replace log of secant theta is square root of 1 plus tan square theta and plus x by 2 plus c. Okay, so here I will replace log of square root of 1 plus tan square theta. Here tan theta is x by 2, just here you can replace x by 2 whole square plus x by 2 plus c. Okay, so now we can simplify this term, log of square root of 1 plus x square divided by 2 square will be 4 plus x by 2 plus c. Okay, and cross multiply, you will get log of, cross multiply this term, 4 plus x square divided by 4 square root of 4. Okay, plus x by 2 plus c. Square root of 1 by 4 is, we can write 1 by 2, so that I will write log of 1 by 2 into square root of 4 plus x square plus x by 2 plus constant c. Is this our final answer? We completed second expression based on problem. Okay. So next, problem number 3. The problem number 3 is evaluate integral 1 divided by x cube square root of x square minus a square dx. Here our expression is square root of x square minus a square. X square minus a square means we can take x equal to a secant theta. Right off. So I'll write here I equal to integral 1 divided by x cube square root of x square minus a square into dx. Right. The expression is square root of x square minus a square. So I will put x equal to a secant theta. Okay. This time I am going to differentiate with respect to theta. Dx divided by d theta equal to a into secant theta differentiation secant theta into tan theta. Okay. So I'll write dx equal to a into secant theta into tan theta into d theta. So now I'm going to substitute all the values in our integral term. Okay. So I equal to integral of dx I will write a into secant theta tan theta into d theta divided by x cube I will write a into secant theta whole cube and the square root of I will write x square minus a square. X is a secant theta whole square minus 1. Okay. Now I will simplify this. Integral a secant theta tan theta d theta divided by a cube and secant cube theta. Here I will write a square, this is a square, secant square theta minus a square. Okay. So I'll write integral a into secant theta tan theta d theta divided by a cube secant cube theta. From this I'll take commonly outside a square into secant square theta minus 1. Okay. So next integral a secant theta tan theta d theta divided by this a cube secant cube theta square root of this a square I am taking outside. I will get a square root of I'll write remaining secant square theta minus 1. This a will cancel. This 1 by a cube taking outside because constant. Integral secant theta tan theta into d theta divided by secant cube theta. This square root of secant square theta minus tan square secant square theta minus 1 I will write square root of secant square theta minus 1 is tan square theta. Okay. So 1 by a cube, this one I will write secant theta divided by secant cube theta. I will cancel one term from this. I will get integral of 1 divided by secant square theta. Okay. Integral of 1 divided by secant square theta and tan theta d theta divided by square root of tan square theta I will write tan theta. Right. So both tan theta will cancel. I will get 1 divided by a cube 1 divided by secant square theta d theta. Okay. So this 1 by secant square theta we can write cos square theta. So that here I will write I is equal to 1 by a cube integral of 1 by secant square theta we can write cos square theta into d theta. Here I'll write cos square theta equal to 1 plus cos 2 theta divided by 2 into d theta. From that 1 by 2 taking outside of the integral because of constant, 1 divided by 2a power 3 integral 1 plus cos 2 theta into d theta. Okay, so now integrate with respect to theta. 1 by 2a cube constant, here 1 theta integration theta, and plus cos 2 theta integration is sin 2 theta divided by 2 plus c. Okay, I'll write 1 by 2 a power 3 theta plus sin 2 theta. I will write 2 into sin theta cos theta divided by 2. Okay, plus c. Then here 2 will cancel. We can write 1 divided by 2a cube is equal to theta plus sin theta into cos theta plus c. Okay, wow. Here we have to replace. Here we know x equal to a secant theta, right? X equal to a secant theta. That means x by a equal to secant theta. From this I need only theta. Theta is equal to secant inverse of x by a. We know now theta, but here we don't know sin theta, cos theta. But cos theta we can write 1 by secant theta, right? Cos theta we can write 1 by secant theta. This secant theta value is x by a. Shift to numerator a by x. So your cos theta is what, pa? A by x. Okay, and this sin theta. Sin theta how to write? Sin theta already we know that sin square theta equal to 1 minus cos square theta, and I will write sin theta equal to square root of 1 minus cos square theta. Okay, so just you can replace here 1 by 2 a cube and theta replaced by secant inverse of x by a plus here cos theta is what, pa? A by x. First I will write cos theta a by x, and sin theta I will write square root of 1 minus cos square theta plus c. Here this cos theta value already we know a by x, just replace that. I will get 1 by 2 a cube secant inverse of x by a plus a by x into square root of, substitute 1 minus cos theta is a by x, so a by x whole square plus c. Now we can simplify furtherly this term. I'll write 1 divided by 2a cube secant inverse of x by a plus a by x. This term I will write, square the term, a square by x square I will get, cross multiply I will get x square minus a square divided by x square plus c. Is this our final answer? Okay, so if you know from this model you can able to get 8 mark. The very simple, you should remember always that expression while you are substituting trigonometric substitution. If you know expression for the substitution x values, now the problem we can solve whatever we can able to solve in this model trigonometric substitution. Okay, thank you, Pa. We'll continue problem in trigonometric substitution in next video also. Okay, thank you.